Hey everyone, looking at the first example that we have right here for combinations, we have the master equation as y equals to fx, and we want to transform the master equation to the three different equations here. Alright, and because we have y equals to fx, we'll be using the AMMA technique, where we have a and m being addition and multiply, and the first am belongs to x, and the last ma will belongs to y. So a and m, translation, scaling, which includes reflection under our scaling. Alright, so looking at the first example, we have 3f bracket x plus 2. So we notice that we will need to do a translation for our x, which is the a right here, and then the scaling for our y, which is the m right here. Which means we will do the translation for x and then followed by the scaling for y. Now, obviously you can do the scaling for y, then do the x right here. It doesn't matter because we're dealing with y equals to fx and everything is in terms of the functions. But when we actually get to actual functions, where it's not just fx, it's something like, let's say, x over x squared plus 2x plus 3, then you need to consider the fact that your scaling would affect the fraction and all that. So it's advisable to stick to this even with y equals to fx. Alright, so let's get the habit right and follow this structure first. So we'll translate first because we now have x to x plus 2. So we translate 2 units in the negative x direction. I'll just write out the full form for the three different types of transformations before moving on to the short forms. Alright, so because we have x being x plus 2, so plus 2, so everything's opposite, so it becomes minus 2. So we have y equals to fx becoming y equals to fx plus 2. Alright, thereafter we have gotten fx plus 2. We now need to multiply the y value by 3, which means it's a scale parallel to the y-axis by a with scale, okay, with is with, you guys know that, with scale factor 3, because I'm multiplying the y value by 3, so it's simply scale factor 3. Obviously you can look at it from y over 3, then you have scale factor as 1 over 1 over 3, which is basically 3. Alright, so we then get the final equation. Now if we were to look at the second question, we notice that we have a scaling for our x, we have the scaling for our y, but in this case it's a reflection because we have a negative sign. Then we have a translation for our y because it is now on the outside for y, or you can look at it as y minus 4. Alright, so we have scaling for x, scaling for y, and translation for y. So we do the scaling for x first. So we will scale, time to use short form because I've already gone through this, scale parallel to x-axis with scale factor. Now our k is 2, so our scale factor is half. Y equals to fx becomes y equals to f2x. Obviously, you can also think about it this way. The new x value will be half of the old x value, so scale factor is now half. Thereafter, we're done with step 1. We now look at the scaling for our y. In this case, it's a reflection. Hence, we'll do a reflect about the x-axis. Now remember, when we do reflection, is the opposite axis because positive y become negative y become positive y, and they are about the x-axis. Alright, now we have gotten y because minus f2x. All we need to do now is just add the 4 to our y value. So think of it graphically, you add every y value by 4. It's a vertical translation in the positive y direction. And then we'll get the final graph. So y equals to minus f2x becomes y equals to minus f2x plus 4. Alright, obviously you can translate then reflect, but it means that you need to scale or reflect your translation. In this case, you have to translate first. You have to translate 4 units in the negative x direction before you reflect about the x-axis. Alright, but I really recommend you just stick with the AMMA method. Alright, so looking at the third example, you notice that now we have everything, right? We have translation for our x, we have scaling for our x, we have scaling for our y, we have translation for our y. So now we should follow AMMA with everything. So let's start with A, alright, the translation. So we'll translate 1 unit in the negative. Again, it's plus 1, so negative x direction, we have y equals to fx becoming y equals to fx plus 1. And now we will scale. In this case, it's actually a reflection, so reflecting the x variable, so reflect about y-axis, alright? Positive x becomes negative x becomes positive x. And you notice that we don't affect the translation at all because we're only applying it to the x variable, which is only on x. So x becomes minus x. Now we've done this, we move on to our scaling for our y. We notice it's a scale of 3, right? Our y value times 3, so it's a scale parallel to the y-axis with scale factor 3. Again, y over 3, so 1 over 1 over 3, scale factor 3. Y equals to f minus x plus 1 becomes y equals to 3f minus x plus 1. Lastly, we have the first part, now we have the first term, now we leave the second term, which is plus 5. Again, your y value increased by 5, so it's just simply moving your graph up by 5 units. Therefore, translate 5 units in the positive y direction, and you end up with y equals 3f minus x plus 1 becoming y equals to 3f minus x plus 1 plus 5. Alright, so that is the y equals fx version for our combinations. Obviously, it's just translating, scaling, and reflection. And we then move to another example where we look at actual equations. Instead of seeing them as fx, we will put fx equals to a proper equation and see what we can do.